So in section 8.3, we're going to be talking about two theorems, the product and the quotient theorem. So the reason for us talking about those two theorems is when we have the rectangular form and then try to multiply two complex number is very easy. We can just follow the FOIL method. For example, the 1 plus I square 3 times negative 2 square 3 plus 2i. To do it, we can just use the FOIL method and it's pretty straightforward. So I'm not going to continue doing it. However, when we're having the polar form, for example, I have 2 cosine of 60 plus I sine of 60 multiplied by 4 cosine of 150 plus I sine of 150. We can still using the FOIL method. However, when we start to multiplying them, we are going to end up in a situations that we have to multiply cosine of 60 times cosine of 150 minus sine of 60 times sine of 150 and similar things like those. It is not doable. However, it just make the process a little bit longer. So the first one we're going to talk about here is the product theorem. So if I have two complex number in the polar form, so I have the first one r1 times cosine of theta 1 plus I sine of theta 1, and then r2 cosine of theta 2 plus I sine of theta 2. So r1, r2 are two different radius, theta 1, theta 2 are two different angles. Then when I try to multiply them, I will have r1 times r2 multiplied by cosine of theta 1 plus theta 2 plus I times sine of theta 1 plus theta 2. So I'm going to multiply them. In this version, it's much quicker and shorter. We can just finding two numbers and then just finding the r1, r2, theta 1, and theta 2. We can just apply it to using the formula. So for example, I want to do multiplication between 4 cosine of 120 plus I sine of 120. And the second complex number, 5 cosine of 30 plus I sine of 30. So quickly labeling them, 4 is the r1, 5 is the r2. 120 is the theta 1 and 30 is the theta 2. So to apply the formula, I will get r1 times r2, so 4 times 5 cosine of theta 1, 120, plus theta 2, 30, plus I sine of theta 1 plus theta 2. So we got 20 times cosine of 150 plus I sine of 150. And if the answer is going to be in the polar form, that's it. This is the answer. If the answer wanted to be in the rectangular form, so this is the polar form, then you're going to continue to multiply them. You got 20 times cosine of 150 plus I 20 times sine of 150. And multiply them together, you will get negative 10 square root 3 plus 10i, and this is the rectangular form. So depending on what kind of final answer the question is asking, then you can either stop at the polar form or you can continue until you reach to the rectangular form. When we try to do division, if I have two complex numbers, r1 cosine of theta 1 plus I sine of theta 1 and divided by r2 cosine of theta 2 plus I sine of theta 2. I can, having the formula, that is going to be r1 over r2 and multiply by cosine of theta 1 minus theta 2 plus I sine of theta 1 minus theta 2. So we can looking at one example using the quotient theorem. So I want to divide 27 times cosine of 45 plus I sine of 45 divided by 9 cosine of negative 180 plus I sine of negative 180. So to do it, we're going to use 27 over 9 multiply by cosine of 45 minus negative 180 plus I sine of 45 minus negative 180. And we will end up with 3 and cosine of, so 45 minus negative, it will be plus, and we got 225 plus I sine of 225. Again, if the question is asking for the polar form, that is your answer. If the question is asking for the rectangular form, you're just going to continue. Cosine of 225 has a reference angle 45 in quadrant 3. So cosine of 225 is going to be negative square root 2 over 2. So I'm just going to write out this part. So negative 3 square root 2 over 2. And then sine of 225 still have reference angle of 45 in quadrant 3 is also going to be negative square root 3 over 2. So negative 3 square root 2 over 2I. And this is the rectangular form. So again, depending on the questions, what kind of answer they want it to be, you can answer either the polar form if they're asking for that, or the rectangular form if they're asking for that.